Once again, they have two topics in one lesson, so we're just going to look at how to add and subtract radical expressions. How can you use radical expressions to determine how far a person can see? The formula d equals square root of 3h over 2 represents the distance d in miles that a person h feet high can see. To determine how much farther a person can see from the top of the Sears Tower than from the top of the Empire State Building, we can substitute the heights of both buildings into the equation and then subtract. Radical expressions in which the radicands are alike can be added or subtracted in the same way monomials are added or subtracted. So if I have 2x plus 7 more x's, that's the same as 9x, or 15y subtract 3y's, I have 12y's. So in the same way, 2 squared root of 11 plus 7 squared root of 11 is 9 squared root of 11, or 15 squared root of 2 minus 3 squared root of 2 is 12 squared root of 2. Notice that the distributive property was used to simplify each radical expression. So I could factor out the square root of 5 out of these three terms, and I'd have 6 plus 2 minus 5. And 6 plus 2 is 8, minus 5 is 3. On this one, we can group the likes together first. Using the commutative property of addition, we can switch order if we like. And then if you want, you can use the distributive property. But honestly, I usually skip that step. And I just say, hey, if I have 7, I subtract 2, I have 1 now. And we don't usually write the 1. 4 from 8 is 4. Square root of 2 and square root of 11 are not like terms, so we cannot combine them. We are done. We're going to have to simplify the radicals first before we can add. So 27 I can rewrite as 9 times 3, because 9 is a perfect square. 12 I can rewrite as 4 times 3. 4 is a perfect square. And 75 I can rewrite as 25 times 3. So square root of 9 is 3. Square root of 4 is 2. Square root of 25 is 5. So 6 times 3 is 18. 8 times 2 is 16. 5 times 2 is 10. And they all happen to be square root of 3's. 18 plus 16 is 34, plus 10 more is 44, square root of 3. Radical expressions with like radicands can be added or subtracted.